Assalamualaikum warahmatullahi wabarakatuh. My name is ImranMohamad, lecture number 1912837 from Federal Structure Algorithm 2, Section 1. So for the final assessment 2, individual question, the problem that I want to solve is, the title of the problem is to detonate the maximum bombs. So let's see the problem. So let's start review the question. So the question is from lead code, and the number of the question is 2101. So the question is in medium level. The question is, you are given a list of bombs. The range of bomb is defined as the area where its effect can be felt. This area is the shape of a circle with the center as the location of the bomb. So the bombs are represented by 0 index to the integer array bombs. Okay, so we have array bombs, and then inside the array we have the x1 and y1 and r1. X1 indicates the x coordinate, y coordinate, and also the radius of the blast. So if there is two bombs, so we have to choose a single bomb that return the maximum number of bomb that can be detonated. So for example, like example 1 here, we have bomb 0 and bomb 1. So if we detonate the bomb 0, there only one bomb is detonate. If we detonate bomb 1, since the radius is touching the center of the bomb, so by detonating the bomb 1 will result in also detonating the bomb 0. So if we detonate bomb 1 in the first place, so the maximum is 2 bombs being detonated because we detonate bomb 1 and also bomb 0. So the input is the bombs, the location of the bombs, and also its radius. Then the output is the maximum number of bombs that can be detonated by a single bomb. So let's say we see the example 2, we have this bomb 0 and bomb 1. So since if we blast detonate the bomb 0, it will not affect the bomb 1 because the radius of blast is not inside inside the range of the bomb 1. And also if we detonate from bomb 1, bomb 0 is not affected because it is out of range. So the maximum of the detonate bomb is only 1, because if we detonate 0, then only 0. If we detonate 1, then only 1. So the maximum is 1. For example, here, example 3, we have 5 bombs. We have 0, 1, 2, 3, 4. So let's say if we detonate bomb 0 here, if we detonate bomb 0, so the resulting is the bomb 1 and also bomb 2 will also be detonated. So we have to check every starting point of the detonation of bomb to give the maximum result. So for this example 3 here, the output is 5, which means one single bomb can produce the maximum of 5 bombs being detonated, which means all 5 of the bombs being detonated. So the constraint for this problem is bomb length cannot less than 100, which means we can have up to 100 bombs in a single array. And then bombs length cannot be more than 3, which means cannot exceed this 3. We only have to input the x coordinate, y coordinate, and also its radius. Then the third constraint is the value of x coordinate, y coordinate, and also radius cannot be, it should be less than 10 to the power 5. So let's see how we going to solve this problem. For example, like we have the example 1 here. The first thing that we need to know, we have to do is to take out all the information available. So we have 2 bombs here, the bomb 0, let's say this is bomb 0 and this is bomb 1. So we have the coordinates here, 2, 1, and also coordinates here is 6, 1. So, and also it is given the radius of the bomb, the blast. So the radius for the bomb 0 is 3, the blast of the radius of blast. And also the radius of blast for bomb 1 is 4. Okay. So the first thing that we need to do is we have to build a relationship because we want to know for each bomb, for each detonation of bombs, which other bombs is being exploded. Which mean like, for example, like we have bomb zero. If bomb zero is detonated, which other bomb that are going to also be detonated because of the bomb zero? Let's say if we have bomb one, let's say if we detonate bomb one, which other bombs in the list that are going to detonate because of the detonation of the bomb one? So the first thing that we going to do is we have to find the distance. We have to find the distance between each bombs. For example, like we have here bomb 0 and bomb 1. In order to find its distance, we just use the Euclidean distance formula, which is x2 minus x1 squared plus y2 minus y1. So since we already have the distance between each bomb, so in order to know whether that that bomb that we calculate the distance is going to affect by the bomb detonation is by comparing the distance and also its radius. So since we already have the distance, so the distance of is less than equal the r of, let's say if we detonate, let's say if we compare the distance between the x1 is 0 and x2 is so the can less than or radius of bomb 0. I mean the bomb that we are going to detonate. So let's say if the distance here between 0 and 1, the distance is 4. Distance is 4, and the radius of this bomb 0 is 3. It is not less than. So the bomb 0 and the bomb 0, if we detonate bomb 0, it will not affect the bomb 1. And then we have to find, let's say in the list we have many bombs. Let's say we have other bombs here. So we have to find the radius between this bomb and also to this bomb. Then we have, since we already find the distance, then we have to compare with its radius. So yeah, after we do all the iteration of each bombs and the distance and also its radius, we will get a relationship between each bomb. For example, like I will do an example here. So for example, the example 3 here, we have 5 bombs. We have first bomb is the 0 bomb, which is the first bomb in the list. 1 2 3 2 3 1 3 4 2 4 5 is 5 6 0. So as usual, the first thing is we have to iterate all bombs to find its distance and also which are the bombs that are going to explode if we detonate the, the original bomb. For example, like we can do a for loop. For example, like for bomb 0, we find the distance between bomb 0 and bomb 1, bomb 0 bomb 2, bomb 0 and bomb 3, bomb 0 and bomb 4, and then we determine whether the distance that we calculate for each bomb does it um less than the radius of bomb 0, which is the 3. So if it is less than or equal than the radius, then that means the bomb 0 have a relation to the bomb 1 and so on. So, and after we do that, after we find the relation for each bomb, which bomb going to detonate which other bombs, then we can produce an agency list. And then after we can create some sort of like linked list, and then we can uh, um, draw a graph from that list to do a traversal. For example, like DFS. we can traverse the graph and then to find the maximum number of nodes that being visited. For example, like here, I already did this. For example, like uh, for bomb 0, it will detonate bomb 1 and bomb 2. And then for bomb 1, it will detonate nothing. Bomb 2, then it will detonate bomb 1 and then.
And then we can, from this, let me draw graph. 0, 0, 1, 2, 3, and 4. So we know that bomb 1, go bomb 1 and bomb 2. And then bomb 2, 1 and 3. 1 and 3. And then 3 to 1, 4. 3 go to 2. Go to 1, go to 4. Then 4 go to 3, go to 2.
So we get a graph here, and then the next thing we have to do is we have to traverse the graph for each bomb as a source. For example, like we can traverse uh, the first traverse is we use 0 as a source, and then the next traverse we use 1 as a source, then next and continue until the last bomb, which is the bomb 4. So for the traversal of the graph, we can see that if we traverse from 0 as a source, we can find that we visit 5 nodes, which means we visit all the nodes here. If we traverse from 1, then we only visit 1 node, which is the first bomb, because it doesn't have any relation to other bombs. For example, like if we start with 2, then we have 4 bombs that are going to be detonated. So from this relation, we can conclude that bomb 0 is going to, if we detonate bomb 0, it's going to be the maximum detonation of all the bombs, because it can detonate 5 bombs, which is all of the bombs, from bomb 0 to bomb 4. As you can see on the explanation here, the best bomb to detonate is bomb 0, because bomb 0 detonate bomb 1 and bomb 2. Bomb 1 and bomb 2. So you go to bomb 1. Bomb 1 doesn't detonate anything, so you go to bomb 2. And then bomb 2 detonate 1 and 3. And then bomb 1, since the 1 doesn't have a relationship, then we go to bomb 3. Bomb 3, bomb 2, bomb 1, bomb 4. Then we go to bomb 4, bomb 3, and bomb 2. So that means if we detonate from bomb 0, it will go through all the bombs. So that means bomb 0 will detonate the maximum number of bombs. So as a conclusion for this problem, the first step that we have to tackle is to find the relationship for each bombs, because we want to create a link. We want to create a relationship for each bombs and other bombs. So the first step is to find the relationship, and in this case is we have to build an adjacency list or something like linked list or something that connect each node to other nodes. Then we create a relationship, and then from that relationship we can traverse the relation to get to count how many nodes that we visit. So from there we can count nodes. From counting the nodes that we have visited from the relationship, we can get the maximum number of the, and then the third one I think is the maximum. From all the counting, get the maximum counting, which is, then we can conclude that bombs produce the maximum number of detonation.